The topic of our talk today is AGS format, 4.1.1 Australia and AGS 4.1.1 International. That should be 4.1.1, with using Datgel's add-ins to produce that to gINT. So the agenda. So I will introduce various things, my company and myself, and then we'll talk about AGS format and the benefits of using it, what's happened in Australia in the last couple of years with that, and the additions that we made in Australia. But in general, the concepts are all very general, overall, if you're not in Australia. And then we will talk about the Datgel tools that relate to AGS format that can support it. And then we'll do a demo of how to set up, configure things in gINT in the DGD tool structure, the toolbox structure, and then export, validate, and import data. So we'll talk about the new validator, and then discuss how you can trial Datgel software and use it going forward. Okay, so briefly about me, I'm a geotechnical engineer. I've been using gINT since the beginning of since I was a graduate, and so initially I worked in geotechnical consulting, but subsequently for the last 20 years, 19 years, I've been doing this sort of work, dealing with geotechnical data management and software development, and I've been involved with developing new AGS formats and aspects of AGS format. I sit on the UK working group and the Australian working group to do that. And I was involved with the Singapore AGS format and AGS RTA years ago. So Datgel, we are a independent company owned by myself, and we develop geotechnical data management software. To date, that's been primarily plugins or add-ins to gINT. And for those products, we have more than 260 organizations in 37 countries using those products. We also have been reselling gINT through the years, and we are now developing cross-platform mobile applications, or just cross-platform applications, to capture and manage data going forward. So in this talk, the initial bit, I'll be talking about AGS format for the next sort of 15 minutes. And when I do so, I will be just referring to AGS format as, the general one, AGS RTA when I'm really meaning AGS 3.1 RTA, and AGS AU when I mean this, full long name here, AGS UK meaning the, uncustomized version from the UK, the original version. So what is AGS format? Now, some of you may know, some of you don't, I'm sure. So AGS format is an ASCII and CSV-like file that you can produce to transmit data between different organizations and different software. It's structured a bit like a database table and fields and columns, and there are rules you have to follow so the data is consistent and reusable. It encompasses a large range of field and lab data for geotechnical engineering, contaminated land and groundwater, hydrogeology, construction, soil and rock testing, and instrumentation. It's been originally developed, and maintained in the UK by the Association of Geotechnical and Geoenvironmental Specialists. And in other countries, you are permitted to extend it and localize it following their rules. So the first version was released in 1992, and the latest version of vanilla AGS format was released in March 2022. That's 4.1.1. And there's this AGS 4.1.1 has an extended dictionary over 4, but it still follows the same rules as 4.0. So how do you create the data or view the data? Well, you can view it and make some small edits practically if you can just open up an AGS file in a text editor, as you see in the back here, this one here. You can also view it in Excel by converting it to an Excel structure or file using the AGS validator, which we'll come to later. And there are some other commercial software that can do that as well. But if you want to do everything, view, create, edit data, you really need commercial software, or have done a lot of work, internally to do that. So gINT Pro and Pro Plus with the Datgel DGD tool Pro add-in is this, supports AGS 4.1.1 and AGS 4.1.1 AU, and Bentley is not developing that in gINT. So if you want to do it with gINT off the shelf, the Datgel DGD tool Pro is the solution for you. There are other commercial software that does support AGS 4.1. And if you want to, you can write your own software to do it, but that would be quite an effort. Now, another thing that's new with this is the UK AGS, Association of Geotechnical and Geoenvironmental Specialists. The working group has created an AGS validator, okay, with some support from some other parties. And so this is the outcome in the Windows version, the Windows app that you can install, extract, and that we will use this in this demo today. So it's the only thing that supports the validation of 4.1 and 4.1.1. The other older versions like gINT, the gINT checker, AGS checker does not properly support 4.1. Anyway, you can download this from that URL, and it does a pretty similar job to the gINT checker. It's in some respects a bit of the next generation of that. Okay, what are the benefits? Why would you do this? Why would you create AGS format and go to that effort? Well, AGS format allows the seamless sharing of data between different software and different organizations within the industry. So if you're receiving data in a standard format, you can immediately import that into your chosen software without having to retype it or manipulate the data and in order to get it in. So it makes it a lot more efficient to reuse the data. Now, the other alternative is, of course, you get a bunch of PDF, 1,000-page PDF, and you just have to, enter a small amount of the data that you must use, for your design or analysis or to form a geological model. And of course, you're really missing out there on some of the other data. You don't bother to do it. So it really helps you be able to quickly produce summaries of the data once you receive an AGS format file. And at the end of the project, it leaves a legacy that can be easily opened in the future because it's just text file. It's not going to be, lose. It's, you still be able to open that in 20 years time or 30 years time and make some use of it. So in Australia, a bit about the history of AGS format there. So in 2000 started in 2006, and then finally in 2007, we released an AGS format that was developed I developed it for the Transport for New South Wales, or at that time called the Roads and Traffic Authority of New South Wales. And this is based on the unreleased AGS 3.2. That's what I was asked to use as a basis by the UK committee. And then I varied it to support some things that they needed. And so it uses different legend codes, graphic codes, based upon what the RMS or RTA wanted then. It has a component description, which was new to AGS format. It has groups for consistency, density, and moisture condition and rock strength, which were not in AGS 3.2. And significantly improved the CPT groups, because what was in AGS 3.1, 3.2 really didn't really do it. And we added a bunch of lab tests as well that were part of the RTA standards. So it's been used significantly since then on all Transport for New South Wales major projects. And everyone in New South Wales, which is where Sydney is in Australia, of course, is well aware of this and using it in the geotechnical community. Now, beyond New South Wales, AGS was used through in other states. Sometimes people in other states would use AGS RTA format because they had the system set up for it. I certainly observed that in Western Australia and Victoria. Sometimes AGS 4 was used. But the problem with that is you end up losing some of the information you need, like rock strength and soil consistency, density, and so on. Although I created AGS 4.0 that had files that had that, or provided, gave the ability for my customers to do that. How many people were losing out on that data who were using other systems? Well, that's a problem, right? So over time, there became a great interest in the Australian Geomechanics Society to create a localization that's standardized so that people could use it across the country, particularly because the new Australian standard for site investigations was released in 2017, and that was more prescriptive. It's changed. I mean, it's still a lot of the things are the same, but it was an impetus to do something, and we waited until that. For some people, that's what they wanted us to do, and there's became a great interest in digital engineering actually over the last decade by far compared to before. So in 2017, I was asked by the Australian Geomechanics Society to create a draft, and then we had a meeting, a workshop in 2019 in Sydney, and then we formed a smaller working group to actually nut it out and go through it and make something that could be used. So finally, in 2020, we released the AGS 4.1. Oh, no, actually, sorry, mistake there. AGS 4.1 was released in the UK in 2020, so we had to switch from 4 to 4.1. And then in 2021, we released some drafts, and finally a final version in 2022 with a few fixes. And there's still a couple of bugs left, but it's not really of any importance. So, but anyway, it's ready to use, and it's ready to go. People are using it. So when we developed this, the philosophy was not to break any of the rules of AGS format, which in AGS RTA we did, some one or two, and not change things that don't need to be changed. Just try to build on top. You support the relevant Australian standards. Learn what was done in AGS RTA and migrate what's useful. Get a lot of input from people. Have a range of different inputs involved in the small group that wrote it, different experiences. So there is, in many respects, there's almost a direct path of data from AGS RTA, but we restructured things like we have one big geol group now rather than multiple subgroups of geol. We used the AGS 4.1 codes rather than the names of rocks for graphics, so to make it more standardized. Basically we took out some things which really were never used in AGS RTA as well, like some more aggregate or more like road testing stuff. Pavement testing was never utilized, to my knowledge. So in AGS 4.1, okay, there's a crazy long list there on the left of all the groups that were added. But if you look at it, you go, well, pinhole dispersion, that's common in Australia. Emerson class is common in Australia. Terms like rock alteration is in the Australian standard for site investigations. So it's, these things are needed. Some of them come down to new groups for the detailed readings of atraxial or something like that, which gives you the option to do it in a standardized way if you wish to transmit that data. Some things we adopted that were in the New Zealand AGS 4, which is, for example, the dilatometer, seismic dilatometer. That definitely was just pretty much a copy paste. Well, some of the ways we broke a bit, I mean, we followed the rules, but we changed, let's put it that way, is we moved GeoGL and Geo2, the geology units, to the independent groups. Because in Australia, it's very much that people think about geological units as an interpretation. They don't necessarily break at the same depths as the material descriptions, because there are things like the rock strength table, might control the break, where you might just have one description that the rock strength has changed. So they're broken out. We left. We added a new field called GL map, but it's still on the GL group. We added the new groups for rock strength, moisture condition, weathering, soil moisture, consistency, density, and alteration. We added extra headings to multiple lab groups for like dates and so on. We use UCS for pocket pentrometer in Australia, so we put that in. And we added some more lab tests. Multiple. You can see on the left there more lab tests and situ tests that are used in Australia. So the GL group, the material descriptions, actually are ultimately created by many groups. It's a combination. So there's the main GL group, which has we'll get to that a bit more in a minute, but there are options about how you enter all the data, but I've said many of these on the left a few times already, so they all ultimately could be used part of a description. Now the GL group can be used in two ways. You can have a very simplified set of data, basically similar to what you might do in normal AGS format, with a few additional columns for origin. So that's basically writing a paragraph with a few bit of extra columns, and then the full extended, which is what the bulk of the working group recommend, is the full description with every column broken down into its own its own aspect of the description, and then software will pull it together at the end. Now, GL description is always populated when you create an AGS file. So the benefits of this granularity is to enable more consistency, in presentation of data. So because the program will create the data, and it allows you to do calculations and against the information, analyze it. It might help you do some automatic checking, and you do selective reporting of the data. And so you could grab the names of material at the certain test depth, like a lab test depth, something like that. So we have created some a website called on GitHub, where you can interact with the group who's written this, and so there's issues, and but really primarily should use the forum, and there's a docs area where we've documented some of what we've done. So this is the place. This GitHub space is where you should interact with us, and there's the link there. And there's also the main Australian Geomechanics website has a page where it has all the final versions of things. That's a bit more easier to find and use as well. So what should you be doing if you want to get in with AGS format? And this sort of describes more about AGS Australia format, but same generally. You should refer to the AGS UK website and the Australian stuff, the Australian website. You should download the documents. You should best use a off-the-shelf software that is designed to do this. Otherwise, you have quite a bit of work to do. You should always validate the data that you create and that you receive using the validator. But you still need to check for completeness, because the validation process is not going to check that every lab test is there. It just checks the validation checks that the structure of the file is correct. And in Australia, you should ask people to use the extended model for GL when you write specifications. So in the case of specifications, I did create a draft specification clause, which I took some of the information out of, a proposed words out of the UK site investigation standard. And essentially you should ask for, the latest version of AGS 4.1 AU, 1.2 or later, and include all the data, use the units defined, use the extended model, use the codes that exist, unless there's something doesn't exist. And you should get the data at the same time as you receive each PDF site investigation report, like with the preliminary report, the final report, and so on. At the same time, you should get the AGS data so you can actually use it at, when you need it. No point getting it 2 months after the project is finished. And it's possible for you to ask for the AGS format data like every day or every week, after each borehole is finished within a few days or something, just like you would with the log. People definitely do that. Now, just want to thank the input from various people involved. So particularly the data, the working group who worked on this: Stephen Durham, Tim Swavely, Tim Thompson, Sven, Lauren. So it was a big effort from all those guys to get this done. And the UK committee who's helped, was obviously written the original draft over the original thing over the years, and still working on it. So if you have any thoughts on that, you can contact us through the GitHub there. So moving on to the Datgel software. So Datgel's gINT add-in solution, our goal is to, overall Datgel's full goal and for everything is to manage, report, and process all types of geotechnical data from one system. And this allows you to eliminate redundant data entry. It's very efficient. You work from one interface and you get great presentation of data. So how does it all work? Well, it sits around gINT. The DGD tool sits around gINT. It's the main product. It's the main product that you would buy if you want to support AGS 4.1. We have a series of Datgel's tools for more geotechnical tasks and some utility tools. And as you can see, this up here is what you install on your desktop computer. And the databases can be situated on a server or an SQL server if you're using gINT Pro Plus, or they can be on your local computer. So the Datgel DGD tool is our main product. It's the one that does primarily support AGS format. And so this is the complete database of all the Datgel's tools in one thing. Not all the tools, but the database. And you can enter the data, store data for all these different types of things. But it's in the sense of calculations and reports, it's designed to produce borehole logs and test bit logs and DCP logs and simple well diagrams and simple cross sections. But it has hundreds of graph reports to present data, but just the results of those, say, lab tests. It doesn't calculate lab tests. So yeah, no lab calculations. So limited number of calculations, except for things related to boreholes. So it calculates SPT, calculates RQD. And there's hundreds of reports provided, and it's designed to work with multiple logging standards from the same system. You just pick the option you need upon, when you create the project. And as an example, logs designed for many countries as well. So there's a program behind it that calculates things and pre-populates things, like the DCP table gets pre-populated. There's tools to import and export data, and it can control the interface that you can see as well. And there are two editions. So the logs edition does not support AGS format, but many of our customers might have a mix of gINT logs and gINT Pro, so they can buy the matching number of DGD tools for the logs and the Pro that they have, and still use the same library and stuff with both options. Okay, the monitoring tool also supports AGS format. So this tool allows you to import data, like in the case of inclinometers, we do import one data file format, or copy paste data in, and then calculates. So basically you enter the raw values you've collected in the field one way or another, and it will calculate the results and present them on graphs and have installation reports and so on. But it's inside of gINT, right? It's a desktop application. It's not a real-time thing. So after the fact, you import or enter the data and produce PDF reports to give to your client. And the Advanced In Situ tool also that data can be exported to AGS format. So it has two aspects. It has Lujon water tests to the Holsby 1976 method, and zone load tests, which is like a supersized plate load test. And the lab tool, it also does calculations following ISO, Eurocode standards and British standards and ASTM standards for various lab tests. And of course, that also, the results can be exported to AGS format. It shares the same database as the DGD tool, so it's all the same thing. These more example reports of what it can do. Now, overall, we have the toolbox, the Datgel toolbox product, right? It incorporates all of our add-in tools. So it has all the other tools, the fencer map tool, the output tool, and so on, CPT tool. Actually, the CPT tool supports AGS format. I think I must have forgotten to put that in my slides. So yeah, also fully supports it. And so anyway, it has all this, the toolbox has all our tools in one price. It's considerably discounted over buying each individual product. But just like the DGD tool, the fencer map tool, that license type called the country seat license, you must buy the same number of licenses, say in the case of toolbox, the same number of toolbox licenses as the licenses of gINT you use or own, hold. So, if you have 5 gINT professionals and 5 gINT logs, you have to buy 5 Datgel toolbox pros, or let's call it Datgel toolbox, and 5 toolbox logs licenses to match the logs. And if you need to use more gINT licenses, you would have to buy more licenses of the toolbox. That same approach works for the DGD tool and the fencer map tool as well. So I'm going to do a bit of a demo now. I'll switch to gINT. So this is the Datgel toolbox trial files. You can download this off our trial page. It's the latest version. Now, at the beginning of your project, I'm just really going to talk about how to support AGS format here, right? So at the beginning of your project, you need to, before you enter any data, you need to come here and define the list filter. It's quite important, it's very important that you enter the right codes. If you want to do AGS RTA, some of the codes are very different to AGS 4.1 AU or AGS 4.1. So you come in here and pick the right one. And less important, but still matter, is like some other localization stuff is required. So pick the right country here, or whatever. And if you're all just using British standard, just use UK. If you don't have an item in the list. And classification standard is also important, but does not affect AGS formats so much. Just other calculations. So you come in here and just set the right settings for your situation. And then when you come to enter data, items in the list here are the right codes behind the scenes. See, we don't actually store clay. We store 201, I think, or 200 or something for clay. Which one it is? Okay, so you start the items. Then you can set, before you export data, you need to come into transmission information export and configure what you want to configure. So it is a good idea to, the concept of this is use like a history of the data that you have entered. Let me just maximize this. Yeah, it is. And so you put in today's date, 6/12. Who's making the file? A description of the data. Getting it. Otherwise, some other things. Now, only with AGS 4.0.4 do you use this column, but you should actually put a description in. Now, if you don't put a date in, it will be populated by the correspondence file. But the concept here is you have a bit of a history of what you've exported, so you can refer to it in the future. Now, the other thing you've got to make sure that is set and that is there by default already is this. The dict table needs to be populated with the correct customized headings and groups that you may export. So I should have done that properly already, but sometimes people might change this and that's a problem. Okay, so we've entered all the data now. And now we're going to export an AGS file. Okay, so it's remembered what I did before. So I'll make a new file here. Right, so the correspondence file, this can be a confusing thing for people. Right, so you can see that it's only showing me the GCX files here. So what this means here is that DTB is this structure, this database. So this database exported to AGS 3.1. If I wanted to do that, I would select that. For our AGS RTA, I'd select this one, or AGS 4.0.4, I'd select that one. You probably wouldn't do that one. That's a bit of everything. This stuff is broken up like this because to export for the Orsted AGS4 format, you need to split up the files into these different aspects of the data. So the files aren't all, not like you don't have one massive file project. Okay, we're not doing that today. This one will, when you do CPT export, it takes the SCPP data from the CPT data correlations, which is a bit irrelevant to what we're doing now. But I think a lot of people doing CPT data export actually want to use that. And you might want to like move that into other files, edit them. So then we have the AGS 4.1. What this 4.1.1, this means just the UK version of AGS format, which we won't do right now. So it doesn't have the extra tables. And this one is the AU version, which has all the extra groups. So we're going to do that one right now, finally. And I'm just going to do that point, because to do one point, just so it's quick. Of course, you can do many point IDs. So we'll click OK. All right, so it's done the export. I don't see any errors or warnings or anything, but I'll just save this. This is my normal practice to save the export log. And click OK. Now I'll make a new project and we'll import the data. So client data template. Find this data template. We'll put it here, 10. Okay, now we import the data. Pick the right correspondence file. Again, there's different correspondence files this time, and there are many because of the CPT stuff. But in this case, is this catch-all AGS 4.1.1 correspondence file. All right, so we'll get that one. And I forgot to validate it. All right, so before we import, we need to go to the AGS validator. And we'll browse to the file. And okay, pick AGS 4.1.1, but I already did that before. And validate the file. Now there will be a couple of issues around these like associated files because they don't actually exist in my file system, but that's it, right? And that's not really an error in the AGS files, but anyway, it says it is. So anyway, if you put stuff in the associated files, you have to provide the file. Otherwise, it's fine, and you can save the validation file here. Let's do that. And you're gonna press the button. Okay, so we can just import this because that is just the associated files. Click OK. I didn't test this before. Let's see how long it takes. It should just be a minute. thing about this point ID that I've done is it has something in every single table, basically, every group. So it has to step through everything. So while we're waiting for that, right? So if you want to take the next step, you'll need gINT, right? So if you don't have gINT installed already, we'll come back to that. So the data is imported. So it tells us what the first bit. It tells us what there was, or all these records, and then what was imported into which table. Through a few things. Then there's like some issues around mostly lookup lists. Fields not found. All right, gotta fix that. Probably not important. And yeah, then lookup list stuff. Yeah, the item's not a lookup list, which is not surprising. So we'll click Save As. Okay. Okay, so the data's come in. I'll come back to that in a minute. So anyway, you need the gINT installer. Now, if you didn't know, Bentley is going to stop selling new licenses of gINT starting the 1st of January. So if you want to buy gINT, this is the time to buy it. And you can download the trial of Datgel's website. If you can look at our docs, which has each of our products has a sort of space in there with a user guide and other like frequently asked questions sort of thing. And if you have any technical questions, you can email support@datgel.com. If you have any sales questions, you can email sales@datgel.com. We have videos. These videos are also on our website, hosted not on YouTube anymore, but they are also on YouTube, and you can look at our website for each of the products. Anyway, let's go back to gINT. It's finished. All right, the data's here, so there should be 1 point. Yes, there should be some material descriptions. Yeah. So it's component description tables. And so on. So it's all here, SPT, let's see, data. All right, good. I'll open the floor to questions. You can put in the chat, you can put in the Q&A. If you have any questions, we can go over them. Okay, well, seems to be no questions today. So thank you for attending, and I hope it was useful. We will post this on our video page on our website in the coming weeks as well. Have a great day.